Hello and welcome to this video on graphing sine functions, and I'm going to specifically focus on how to graph the sine function. If you missed the first video on kind of the concept and the idea going on here, make sure you go back and watch that. But here in this video, I'm going to talk about the steps. So the first thing that you want to do is you want to separate the period into 4 parts. So step 2 says plot a point on the x-axis at the beginning of the period. Well, in the last video we talked about the sine function. It starts at the origin and it has a period of 2 pi. So here is the first and last point of the period. Step 3 says plot a point on the midline, the x-axis, halfway between the beginning and the end of the period. So if I split this, and this is kind of step 1, if I split this into 4 parts, here is splitting it in half, kind of like how you cut a pizza. You cut a pizza straight down the middle first, right? So I'm going to plot a point here on the x-axis. And then I have to cut these 2 halves in half, right? So if I slice this kind of down the middle, slice this down the middle, I now have to plot a point at the maximum. So that is up here, right? Halfway through the first half. And then I plot a point at the minimum. This is step 5, all the way down here. Okay? So these are all your main points for graphing the function. So I go up, and I draw a smooth curve. So there is my crest, if you will, and if I go down here, I graph my trough, and there it is, right? Crest and valleys, hills and valleys, if you will. Okay, so don't connect the dots. It's not like a, notice this point, this is more curved through here, and not like a V. Okay, so here is again that process. And there is the sine function. So in this example, it says graph y equals sine theta for 4 periods. It wants 4 periods of graphs. So I'm going to go ahead, I'm going to start at the origin, and I'll plot my first point, and I know the period is every 2 pi. So there's my first and end points, and then I'll split it into fourths. So here's halfway. Okay, I have a point here. I know there's a point here, and sine function goes up, then it comes down. Also, too, remember that the maximum is at 1 and at -1. So here is a rough sketch of my sine function. And notice that this is just 1 period. They want it for 4 periods. So we have to go ahead and repeat this. So again, I'll start here, I'll end here at 4 pi. I split it down the middle and then split it again. So I have another point here, a maximum, and then a minimum. So my function, okay, there's 1 period. And then I need 2 more periods, right? That's 2 periods, so I need 2 more. So now I can go back 2 pi. It works just the same. Okay, so, but instead of having it starting with a maximum this way, this has got to be a minimum. This would be a maximum. So here's another period, and 1 more time. So minimum, intercept, maximum, intercept. Okay, and here is my graph. Okay, so that is y equals sine of theta for 4 periods. At this point, I would like you to pause the video. I would like you to graph y equals sine theta for 2 periods on your own in this example. So again, please pause at this point and try this one on your own. Okay, so hopefully you have paused it and tried this on your own. And this is the graph that you should have gotten. Okay, at this point, I want to talk about this word amplitude. Please say that, amplitude of sine functions. Amplitude, this is the height, how far up and how far down you will go. Okay, and it's denoted generally with a value in front of your sine function. It's known as the a value. And also too, this is the absolute value. So even if you see -3, -4, the amplitude will be the absolute value, so just the positive value of that. But if you do have a negative value, it will cause A to flip. It'll cause a vertical reflection. Okay? So let's look at this. So this example says, state the amplitude for the function y equals -2 sine theta. Well, again, the amplitude is the absolute value of the a value. So the absolute value of -2 is just 2. Okay, so the amplitude is 2. Here's a practice problem, and this is fairly simple. What is the amplitude of the function? Well, again, what is the a value in front of your function? 6. So it has a amplitude of 6. And if you're thinking about this in terms of other graphs that we've looked at this year, your a value causes vertical compression or vertical stretch, and in this case we're stretching the graph up 6. So I wanted to show you kind of what this looks like. So here is the sine function graph, and what I'm going to do is I'm going to I want you to see this too. So I'm going to stretch this a value. So here is your parent function, and watch what happens to the maximums and the minimums as I stretch this. So if I go to 2, notice now my maximum's at 2, minimum's at 2. If I go up to 6, right, now I have maximums and minimums at 6 and -6. Okay, so that's amplitude. It's the a value in front. If you want to kind of see here, I'm just manipulating this value right here. And I want to show you reflection. So what happens? So as soon as I lower it, you see it's compressing. And then when I get, please pardon that bell, as soon as I get below 0, notice that it reflects. Okay, so instead of now going up from 0 up to my maximum, now it's going down. Okay, so we get reflection when we have a negative value. Okay, I'm going to stop the video here. I would like you to please watch the next video. It's going to go over just a couple more examples about graphing sine function with amplitude. Okay, so again, in this video, we graphed how to graph the parent function of sine, and we introduced this idea of amplitude.